Hello, my people. How are you? How on a day? Hope on they do well. This one are your brother man, your lecturer, Dr. AMG. Now today we will continue. They do small. They go. I know we'll talk plenty things today. uh You know, say for this topic, we dey for this course wey we dey do now, we dey hammer on calculus. And we say we don't give am name, code, and the code na mass 102. Mass 102. And we say the course wey we dey do na wetin we wan really learn na say na calculus. Now inside this thing for other class dem, as una know, we don look the calculus in different area. Mainly we dey look at function now, wey we say na im be the real foundation wey calculus dey really use. Na so we talk. And when we say calculus, we dey talk about more of differentiation and integration. Now for the sake of today's class, we go learn piecewise function. There are some functions wey dem dey call piecewise functions. How those ones dem dey? Piecewise functions. Now these piecewise functions, how these things dem dey? Now make una lis ten. By the time we finish today, una go really understand wetin piecewise function be. Now piecewise function na function wey get other functions, other small function na im make am up. That kind thing. Make I write am make you see. Now those small functions wey we dey talk about, dem get their own domain o. Dem get their own domain. And as we dey do dey go, you go dey see say dem go get their own range too. Because some wey get their domain, you fit from there find their range too. So make I give an example of wetin I dey really talk about piecewise function. Example na something like this. This one are the function dem, 8, 4, and 5. But for this one, im get domain where we get -1, where x dey take value -10 dey less than x less than equal to -6. For this other function, we get -6 less than x less than equal to -2. For this other function, we get -2 less than x less than equal to 6. Now, make una look this function wey we get. Now, this one now na function wey this other ones na im make am up. E just dey like one woman wey get belle, wey get 3 children inside her belle. This one wey una see here na function. Im get im own domain. This one sef na function. Im get im own domain. This one sef get function and im get im own domain. So all this one, you fit call this one now small function. Function f1, function f2, function f3. Small function. All these ones na im make up this function. This type of function wey we get so, na im we dey call piecewise function. Now, as we keep am like this, some people fit no really understand. Now make I draw am for board. Make we draw am for board so that una go really see wetin I dey talk about. Now, if we wan draw am to demonstrate wetin we really do, see wetin I wan do. See wetin I wan do. For the x value, for the domain values dem, the smallest value na -10 and the biggest value na 6. So -10 and 6. So make I take from here to here, make it be -2. From here to here, make it be -4. From here to here, make it be -6. From here to here, make it be -8. From here to here, make it be -10. Here go be then 2. Here go be 4. Here go be 6. Here go be 8. Here go be 10. Now, for the function then, you know, say this our vertical line, this our f of x, and then be the function here. The function then, the smallest number na -8, and the biggest number na 4. So if the smallest number na -8 means we fit still do similar thing, where here go be -2, here go be -4, here go be -6, here go be -8. Then here go be 2, here go be 4, here go be 6. They don't dey okay. Now make we plot the graph. Now this function the way we get in these places, this one we dey call them constant function. Dem be constant. They no dey like the other ones the way we don this one na constant. They are all functions, but they are called constant function. Na number, variable no dey. Those ones wey variable dey, all those ones we don consider before na algebraic functions. But this one na constant functions. Now, make we see am now. When it be -8, when it be -8, see the interval wey in dey. When it be -8, -8 na somewhere here. When it be -8, say for the x value, say in dey for -10, in start from -10, then in go to -6. In go up to -6 here. But see the way I use write am. When e dey start, I no shade this side. But when e dey end, I shade am. Any place where I shade like this, e dey mean say na there e dey end. Now wetin make I do am like that now? Say -10 is strictly less than. So say -10, you know they take the -10. It's strictly less than x, but less than equal to -6. But say the -6 follow. The -6 follow. But -10, say it dey less than the -10 no follow. Now I put am like this. Now make we look the second function. Wey be 4. When e be 4, for the x e dey for -6 strictly less than. Then this one e dey for less than equal to -2. When e be 4, 4 na here. E dey strictly less than -6, so from here. But we no go shade am because e dey strictly less than. Then e go come to -2. -2 dey here, e come take -2. So I come shade that one. Now the last one na -5. 5 go be between inside this place, between 4 and the 6. So inside this place, -5. Now for the -5, say in start from -2, but strictly less than -2. So we no go make am dark. In pass like this, up to 6. Say this one come till they come reach here. But the 6 is less than equal to. X is less than equal to 6. So the 6 self take am. Now, this information wey dey here, wetin we write here, na here I don draw from here. Now if you look now, this one na one function, this one na one function, this one na one function. Pieces of different function na im make that function. And these pieces dem wey we get, wey be function, get their own different interval wey we dey call domain. So this kind thing na im we wan learn. Now other class dem wey we don learn, if una fit remember, we don't learn about how to look for the range, look for the domain, and also the range. Now, somebody fit ask question, say, sir, why e be say this time now na number, constant, na im you use? Another type no dey, another type dey. For piecewise function, we fit write am in terms of algebraic functions. We fit write am in terms of algebraic functions. The piecewise function, we fit also write am as trig functions. We fit also write am as absolute value function. We fit write am as different ones, no be only like a constant function. Now make we consider some example to really see how we go fit maybe use look for determine the domain or the range. These functions then, we fit even solve them the way we been do at that time, where we get f of this of x, where this one we fit find and evaluate them at a particular point. This one we fit evaluate them at a particular point. Say this plus g of 3. We fit evaluate all these ones at a particular point. All these kind of things that we fit do them with a piecewise function. Now make I do some example, make we really see. In these ones, the one we will do, we will try to determine the domain and the range of this main function. Make I do some example, make we see. Now make we consider this example wey we get for here. The example say, na piecewise function x plus 1, where the domain na x is less than minus 1, and we get x squared, where the domain na x is equal to minus 1. Then we get another one, x plus 2, where x is greater than minus 1. I want make we look this function wey dey. Based on the first one wey I don write before, person fit tell me whether this one na piecewise function or no be piecewise function. Now, if you look this one, e dey clear say this one na piecewise function. Na piecewise function be this. Now, if na piecewise function, the question wey I wan ask on na find the domain and the range of the function of this function of the function f of x. We fit find am? Yes. Now, wetin we wan do for here for domain? Somebody fit say, but sir, this one get im own domain now. This one sef get im own domain. This one sef get im own domain. Now, wetin we wan do here now? All these ones na small functions wey all of them na im make up this one. Just like I said, woman wey get belle, wey get 3 children, na im be this. Now, because im be function, im get im own domain. Because this one na function, im get im own domain. Not like this one na algebraic functions. This one sef get im own domain. So wetin we wan do now? Na to try to see how we go collect all this domain, use form this one domain. Make we see wetin we wan do. For the first function, make we call am f of x1. That is for this one. For the f of x1, the domain value the way in get, the domain value the way in get, but f of x1, the domain value wey in get na wetin? Wetin dey here na say x is strictly less than 1. Strictly less than, it means say e no go take that 1. The number dem, all of them go must dey smaller than 1. E go must dey less than 1. Now, if e go must dey less than 1, wetin be the first one? E go be -2, -3, -4. Na so e go dey. Because say e dey less than. So the values dem wey dey for that one, say na s dey take -2, say e dey take -3, -2, -3, -4, on we go to negative infinity. Na so e dey go. For this other one, the second small function, make we call am f sub 2 of x. Wetin be the domain value wey dey here? This one na no be interval. This one say x is equal to -1. So this one dey straight away. Say this one say x na -1. Now for the third small function, this one na interval. E say x is greater than -1. Say x, the value wey x dey take go big pass -1. So if e go big pass -1, then wetin be those numbers? 0 big pass -1. 1 sef big pass -1. 2, so e go from 0 go up. So meaning the value dem wey dey for that last number for the f3 na 0, 1, 2, and so e go till positive infinity. Now, wetin we wan really do here na to collect all these one dem, use form this one domain. You know say the thing that wey we write here na the domain of this function dem, na im we write here. So wetin we wan achieve na to collect all these ones, use form this one domain. Make we do am see. Now, if you look here, 0 dey here, 1 dey here, 2. This one go till positive infinity. Now, if you dey come this side, because we wan collect all, this one go come follow. E go come be -1, -2, -3. So you see say we dey get 0, 1 to infinity, 0, 1 to negative infinity. So the domain of this function, by the time you collect all the other ones as we don do, the domain of that function na negative infinity, because when you collect these ones negative infinity, then plus this one, if you come go this side, all will be positive infinity. This one will be the domain of that function. No be for this function though, but for this function wey we dey talk about. Because this one na im we dey now talk about. Now, if you don't get the domain, you fit also look for the range of the function. Now, make we look and see. The range of the function. We don tell you say function na something wey dey take in x values to itself, then you go output y value. Now, look am now. For this function now, see the x values there. So we wan take in x value to this one. We wan input to see wetin im go bring out as range value. So that we go put am here. Now, the first term wey we get here na -2. If we put -2 for this one, you know say now because from here na im we get this upper part. This one na for this. This one na for this. We no go carry this one go put for up. No. This one wey dey here na im get this one. So we go use this one for only that, for that up one. So if you put minus 2 for here, wetin go happen? Minus 2 plus 1, the answer will be minus 1. If you come put minus 3 for here, the answer will be minus 2. The first one is minus 1, the second one will be minus 2. If we put minus 4 for there, you go come get minus 3. Now so e dey go, now so e go till you go reach negative infinity. The more you dey consider the number, now so you go dey go to till you go reach negative infinity. Now make we come put this one, impute this one into this one. After all, this one gets only 1. After all, this one gets only 1. Now, if we put negative 1 into this one, what will happen? Negative 1 times negative 1 will come give us positive 1. So you go see, say, for this second function, the range value, the output value will give us now positive 1. Now, when it comes this place here, the domain values there now this one, 0. Now, so it can go up till infinity, positive infinity. So if you put 0 first for here, what is the number we will go get? We will get 2. If you can't get 1, you go can't get 3. But first of all, if you put 0, you go get 2. If you can't put 1 there, you go can't get 3. If you get 2, put 2 there, you go come become 4. Now so it will go till it will become positive infinity. Now, as we do for the domain, now so we go now collect all these ones for the range, so that it will become the range of this very function. Now, if you look at these ones then, you see say here, from 2, 3, 4 to positive infinity, 1 day here to come, they collect all. So if you put 1 here, it will be 1, 2, 3, 4, they go. If you come this side now minus 1 they start with, meaning something they miss for this place here. And what if they miss? Now 0. Because this one they start with minus 1. 1 day here, from 2 up to positive infinity, but something there where they miss, and that thing na 0. So the range where that function gets 0 no day. So we go comot 0. So how we want use write am? See am. The range go be minus infinity. Say 0 no day. So if we put 0 for here, can't use this bracket. This one means strictly less than 0. Say 0 no follow. Now from minus 1, now the meaning be this. Now if you don't like this one, you go come put minus infinity, comma, minus 1. If you put the minus 1, see the bracket where you go use. These two statements are the same thing. If you use this type of bracket, it means say these 2, 6 no follows. Now it's strictly less than, say, now the other one number where they less than 0, now you go take. Now union, but remember, all the number, the only thing we know day, now 0, now you know day. Now 0, now you know day for here. So that's the thing we try to write. To positive negative infinity to positive infinity. Only say 0 no day. So that the 0 now you will try to come out soon. So for this other side now you go come write 0 no day now. So if I put 0 here, mean is strictly greater than at the meaning to positive infinity. Now if I don't want this one, I fit also write them as the thing start with 1 from 1. So I will say 1, comma, positive infinity. Now, if I use this one and say this one now, it follow this one greater than equal to, now in day for here, now the meaning be this. So these two things now, now the same. So this one, either you use this one or you use this one. Now the range of this very function where we get based on these smaller functions where we get. So I see as the thing sweet. Now we consider another example, see how the thing will be. The next example we I want to give. Now something where all of us will also like. Now, if I can say, make the function be x, where x is less than 7. Make I give you another function, being say a piecewise function we dey talk about. Now, collection of small small function will make the big function, where x is greater than 7. Now, the question we will go ask here now, find the domain and the range of this one. Based on wetin we don learn before, somebody fit tell me wetin we go do. Somebody fit tell me wetin we go do. Make una tell me wetin we go do. Now, first of all, na for us to look the domain wey dey for here, collect am. Look the domain wey dey here, collect am. Then we combine all the domain, use form this one domain. So make we do am see. The first one, wey we dey call small one, f1, the domain values dem wey dey there na x is strictly less than 7. Meaning x go take 6. It's less than 7. So x go take 6, e go take 5, e go take 4, e go take 3, e go take 2. Now so e go till negative infinity. Till negative infinity. That's so e go. Now the second small function wey we get here, say x is greater than 7. X is greater than 7. It means say x dey take number from 8 dey go, e greater than 7, strictly greater than 7. So x go take 8, 9, 10 to positive infinity. Now so this one go. So now for us to get this one domain, now for us to collect this one and this one, join them together. But if you look the two here, we get 6 till negative infinity, but 7 no dey here. But 8 dey. 8 from there, 9, 10 till positive infinity. So the domain of this function wey we wan collect, so 7 no go dey. 7 no go dey. So if 7 no go dey, how we go use write am? Make una see am. This thing wey una dey see sometimes una wey dey write exam, e dey dey for exam well o. So make una see the way I dey use write am, so una go really understand wetin we dey talk. Now we wan collect all these ones, but 7 no dey. Remember, this one go from here 8 to positive infinity. That one go from 6 to negative infinity, but 7 no dey. So how we go use write am? Say negative infinity dey. Then say a end for 6. So if you end for 6, if we put 7 here, see the type of bracket wey we go use. This one dey mean say e dey strictly less than 7. Na the meaning of this bracket. Now if you no like this one and you wan put the 6, then you go say infinity, comma 6. When you don put the 6, you go put this one. When you put this one, then you say this one is equal to, less than equal to 6. Say the 6 follow. And the meaning be that. Now, union, no say we dey combine all of them. Wetin we don write here na just for this side. Now this other side na from 8 down, 7 no follow. So this one, if you write 7, comma infinity, this one dey show say e dey strictly greater than 7. Strictly greater than, na the thing wey this bracket dey show. Strictly greater than 7. Strictly greater than 7 to infinity. Now if you no like this one and you wan use the 8, then you go come say, you go come put this other bracket, say 8, comma infinity. And so you go come write am. So this one wey we don write here now, na the domain of the function. The domain of that function, based on those small functions dem wey dey for there. Now the next thing wey we go come find here na the range of the function. How we wan use find the range of the function? How we wan use find the range of the function? You dey see say that one sef dey straight away. Na just for us to carry this value dem, put inside. When we don't put am inside, you go come output. The thing when you go output, now it be the range. Now, make we check the first one, where we dey call small f1. Now, the first number wey intake na 6. If we put 6 for here, it go bring out 6. If you put 5 for here, it go bring out 5. If you put 4, it go bring out. So anything wey you put for here, because na only one x dey, it go still bring out that thing. So for that same thing, na still like the same thing. To negative infinity. Na the thing wey you go output. Because say na only x na im dey for here as a function. Now for the second one, for the range how e go be, make we impute these things dem to see wetin im go output, wetin im go bring out. Now if we put 8 for there, e go be 8 plus 1. If you put 9, e go be 9 plus 1. So the first one, if you put 8, e go be 9. If you put 9 again, e go be 10. Now so e go to positive infinity. Now for us to get the range for this one, we need to combine these two so that it will form the range of that one. Now make we combine the two. Now make we look. This one now, 6 day, 5 day, 4 day till negative infinity. This side 9 day, 10 day, 11 day, 12 day till positive infinity. But there are some numbers where day wey no day. Where be wetin be those numbers then? You see say 7 self no day, 8 self no day. So the range of that function, 7 we go write am, but 7 self no go day, 8 self no go day. How we wan use write am? Now based on wetin we dey do now, some people fit don already dey write am by themselves. Remember say negative infinity dey, so na im we go start with, negative infinity. 7 self no day, 8 self no day. Put am for your mind though. So for this other side, being say we dey combine them, for this other side, if we put 7, meaning that we go put this one, but no say 7 no dey. Now I dey use this bracket. Now this bracket dey tell us say this interval now, say e dey strictly less than 7. Say 7 no go follow, say e dey less than 7, and the meaning be that. Now if you no like this one, say na the way e dey I wan use write am. This one sef na so e dey. But if you say that the 6 I wan use start, then you go say negative infinity, then 6. If you write the 6, see the bracket wey you go use. Then if you no do like that, then plus this other side. Na im make we dey put union. When you don put the union, I don put this bracket again. Because I don put this bracket, I go put the first number wey I go put na the number wey no dey before this one. And wetin be that number? Na 8. This one dem go say strictly greater than 8. Na im dey for here. Then to positive infinity. If you no like this one and you say you wan write am the way this one dey, then you go write 9. Say 9 follow to positive infinity. Now wetin make I dey write these ones, or na when they write exam sometimes, when you don go CBT, all those objective questions there, no be you go write am. Na dem go write am, you go come look, come select. Na im make it dey important for una to really know which one be which. So that if na this one dey, you know the meaning. If na this one dey, you know the meaning. So wetin we don write here now, na the range. Wetin dey here, na we don use put for here. For una exam dem no go write this kind of thing. Na this kind of thing na im dem go write give una. So make una really know wetin we dey do. Now make we consider more examples so that we go really understand and enjoy life. For me, I like mathematics because mathematics sweet. Make we consider one example again, so that people go say, as I teach us this one, but then come give us this other one. How this one come be? Make we consider another example. Make we consider another example. Wetin we wan consider now, see the way e go dey. 3 over x, where x is less than equal to 1. This other one now, x minus 1, where x is greater than 1. As usual, the question wey we dey ask now, find the domain and the range of this function. This smaller function dem na im make this one. So we wan find the domain. This one dem dey get their own domain, but we wan find the domain of this one. But one thing wey I wan tell una, when we dey find the domain of this one, because of the way this one dey, you know say this one now, numerator dey, denominator dey. The denominator no go become 0. If the denominator becomes 0, wahala don dey. That kind mathematics no dey. We dey say for English, we dey say na undefined. That kind mathematics no dey. So the under no go become 0. So when we dey take the domain of this one wey we wan find so, we no go put under 0. Because if we put am, that kind mathematics no dey. So anything wey go make this under, and the only thing wey go make this under to be 0, na when 0, x takes 0. So for the interval, if x 0 dey, we go comot am. Make we look wetin we wan do. Now, even for this one sef, we get small f1 and f of f2, because na two functions na im give birth to this big function, f of x. Now, for the small function, wetin be the domain dem wey dey there? Dem say x is less than equal to 1. Two statements, less than, then equal to 1. So make we consider the less than side first. X is less than 1. So wetin be the x values there wey go dey? If x dey less than 1, the first thing go be 0, minus 1, minus 2, minus 3, on to negative infinity. Now, but dem still say x is equal to less than, na we don write now, is equal to 1. So means x still dey be equal to 1. Now, for the second function wey we get, f of 2, the second one, say x is greater than 1. Strictly greater than 1, meaning x go take number from 2, 3, 4, 5. 2, 3, 4, 5 to positive infinity. Na so it go take. But remember, I say, if we put these things then inside this one, like this 0, if we put them inside this one, it will make this one to be undefined. I said that kind of mathematics no dey. Because that kind of mathematics no dey, this range wey dey here, we no go take this 0. We no go take something wey go make that thing 0. So we go comot this one. Because if we put am, e go make that one 0. So we go comot am. If you put this one, e no go make am 0. If you put this one, e no go make am 0. Na only 0 wey you go put there wey go make that thing, that kind of mathematics no go dey. So we don comot am. Now if we don comot am, then make we now combine these two, so that it will become the domain of, it will be the domain of this function. Now make we combine the two. Make we combine the two. If we combine the two, the way we are not use teach now, you know say this side dey give infinity dey, so na here we will start with. But if go up to minus 1, you know say 0 no dey. Here 1 dey, 2 dey, 3 dey, 4 dey to infinity. But wetin no dey here na 0. So we go comot that one. So if we dey comot that one, we go say this one to 0. If we put 0, meaning say we dey say we go na this bracket we go use. Na this bracket we go use. But if you say you wan write am the way wey the thing dey exactly, then you go say this one, then you put minus 1. If you don't put the minus 1 as e dey, then see the bracket wey you go use. Union This other side, 1 day, 2 day, that's what you did. So you go say 0. And they use the 0 because of this type of bracket wey I don't use. To infinity. But if you don't like this one, say you want write am the way e dey, 1, 2 way e dey, then you go say this one, 1, comma, positive infinity. Na so e be. So this one wey e dey, this one and this one, they are all the same thing. But I dey write the 2 for now. Because we no go know the one now when they go write exam, we no go know the one wey dem go give una for exam. So make una really learn the thing. Understand wetin I dey try to write. Because the thing na potopoto. Now when we don't know wetin the domain be, the next thing wey we wan do na to find the range. This one now is the domain of this function, na the domain wey this function get. And in that domain, 0 no dey. Because if 0 dey, e go make that function undefined. We no want that kind of thing. Now, the next thing we want to do na to put the domain value dem wey we don get into the function dem, making output range values so that we go also find the range. Now, for the first function now, the first term wey we get na 1. But make I no do that one for now. If I do that one for now, e go dey like say everything wey we dey do na me dey do them. So make una go find the range. I want make una go find the range by una self. So wetin I dey talk be say the class should find the range of the function f of x using these ones that we don't get. We're going to use and find the range. Remember, this one and this one, they go for the up one. These ones then, they go for the down one. We're going to use and find the range. Now, if I don't find the range, make I do another one, make I show another example. Make I show another example. And that one square root of 1 minus x, comma, where x is less than 5, then x plus 1, where x is greater than or equal to 5. The equation is find the domain and the range of this function. Now, based on what I don't give on that, this one says we get two small functions, we make the big function. Now, in that one where we don't get, wahala self dey o. Wetin be the wahala wey dey? Now, because of this square root sign wey dey here, when we dey find this one, we go dey very careful because we no want something wey go make this one give us complex number. Anything wey go make the thing complex number, we no want. Wetin I dey mean? If you find something, you go put number wey be maybe -1. You know say this one now na complex number I. We no want that kind of thing. Once minus dey inside the square root bracket, it go give us complex number. So anything wey go make minus dey inside here, we no go want am. We go comot am for this the domain of this big one. So we go dey very careful. Now make we write out the domain wey dey for there for the first one. For the first one, they say x is strictly less than 5. Strictly less than 5 means x will take 4, x will take 3, less than, x will take 3, x go take 2, x go take 1, x go take negative number 0, x go take minus 1, on to negative infinity. Now for this other one, say x dey greater than or equal to 5. So 5 sef follow. Say 5 follow greater than. So 6, 7, 8 to positive infinity. Now, make we test this thing then to really see whether this one the way we don't like as e dey there go in for that go inside that first one. Because we don't want to say when square root don't sign on dey, we go dey very careful. Because when minus don't dey inside the square root bracket, a number wey get minus dey inside, say e go make that thing complex number, and we don't want that kind of thing. Now make we look at it. Now if we put the 4 as this statement dey, if we put the 4 here, we go get 1 minus 4. And when we do 1 minus 4, the answer will be minus 3. This kind of thing we don't want am. We don't want am because this one dey the same thing as minus 1 times 3. And this one you fit write am as minus 1 times root 3. And this side now na complex number. We don't want am. We dey together with this one. We don't want complex number. So meaning anytime when minus don't dey, we don't want. So this one wey we get, we no go take am. If you put 3 for here, e go make this one 3. Now 1 minus 3 go give you minus 2. So this one sef we don't want. If you put 2 for here, 1 minus 2, e go give you minus 1. And minus 1 na I. We no want am. If you put 1 for here, 1 minus 1 will give you 0. Square root of 0 is 0. That one dey okay. Wetin we dey avoid for there na something wey go put minus wey go make the thing complex number we no want. So these things that wey dey here, we no want. Meaning say the new domain wey we want for this function, say these ones dem no go dey. Now, as we don't know am like that, make we now combine all of them. If we combine all of them, how the thing go be? How the thing go be? Make we combine them. Remember here 1 day. If you put minus 1 inside this place, that one go because minus times that minus 1 go make am plus 1. So 1 plus 1 go be 2. So all this minus 1 them go work. So if we dey combine that thing, you go see say 1 dey but 2 no dey. 3 sef no dey. 4 sef no dey. But 5 dey. Na that kind thing na we wan write. 2 sef no go dey. 3 sef no go dey. 4 sef no go dey. But 5 up go dey. Because this 5 up now, somebody will say, when you put 5 now, it go up. This 5 wey we get, no be for here. The 5 now for this side. This one wey we write now for here. So when you dey talk about this side, now only for here. This one now for this side. So if we bring all together, wetin we go get na negative infinity dey. Comma 1 dey for here. But if you want write this one using a different bracket, say this one if you put 2. If you put 2, see the bracket wey you go use. If you use this bracket, they say the things the way you want, they're strictly less than 2. Meaning you go start from 1 at the meaning. But if you say you want write them the way it did, then you go say minus infinity, then 1. When you don't use the 1, see the bracket where you go use. Now, when you want write this side, you say union. If you use this bracket, means you no go take this one. You go take the one where they less will be 4, comma, positive infinity. This one dey mean say the number dem wey we need dey strictly greater than 4. Wey you go come dey give you 5 odd. But if you say na like this you want am, then see wetin you go write. You go put this bracket, then you go put 5 comma infinity. That one na im be the domain of the function. Now when we don find this one, the next thing na for us to find the range. Class, make I leave this one for una too or make I do am? Make I leave this one for una too or make I do am? Now, if you say make I do am, make I do this one now. Remember, say this one are the domain value for the up one, this one are the domain value for the down one. Wetin we wan do now? Now to allow this one, make the function take this x value so that we go output the range value. Now, when this one, when x takes 1, wetin im go output? Im go output 0. If 1 come here, 1 minus 1 will give you 0. Square root of 0 na 0. If 0 come here, 1 minus 0 na 1. Square root of 1 na 1. If minus 1 come here, we will get minus times minus 1, it will be positive 1. And 1 plus that 1 will give us 2. If you come minus 2, it will give us 3. Now, so it will go till positive infinity. Now, make we come this side. Make we come this side. If you come this side, if 5 enter here, you go see say the answer wey you bring out na 6. Because 5 plus 1 will give us 6. Now 6. Now if you put 5, if you put 6 into this place, you go come get 7. If you put 7, you go come get 8. Now so you go still go till infinity. Now this other one, I forgot to show on the square root part. Now when you put 1 minus 1 will give you 0. Square root of 0 na 0. Now it be this one. Oh. Now this one, why we get this one now? If we put 0, 1 minus 0 na 1. Square root of 1 na this one. Now, wetin make I write this one 2? Now, if you put minus 2, you go get minus 2 here. You go times this one. You go come make am 3. I mean, if you put minus 1, minus 1 come here. Minus times minus 1 will give you 1 plus 1. If you add them, it will give you 2. Now, square root of 2 will give you 1 point something. You go see say the next number now go dey bigger than this one. If you go reach 2, minus 2 come here. Minus times minus will give you plus 2. This 1 plus that will give you 3. Square root of 3 will give you 1 point something. Wey go dey still bigger than the number wey you don get. Now, wetin make I write these 2 now? If you come get up to 3, when you don't put 3 for here, minus 3 for here, minus times that minus 3 will give you positive 3. 1 plus that 3 will give you 4. Square root of that 4 and 2. Now, you make I put this one. Now, if you come up to 8, minus 8 times minus 8, now positive 8. 1 plus that 8 will give you 9. Square root of 9 will give you 3. Now, if you consider you can reach maybe 15, you go see say minus 15 times, minus times minus 15 will give you positive 15. 1 plus that 15 go give you 16. Square root of 16 na 4. Now so the thing they go on we go. Small, now so they increase they go. So now so you go increase you go reach positive infinity. Now for this one, this straightforward, this side said this straightforward. Now what we want to do now to combine these two wey dey for here. Now when we dey how we wan use combine am? If you look at this one now, you dey see say this under one start with 6, 7, 8, 9, 10 up. While this one start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one na subset of this one. All of them are the same thing. So this one go to 6. After 5, then 6. It continues from this one. So meaning say the range we will get now from here to positive infinity. So the range number we will go get now -1, comma positive infinity. Now so we write that. Now this one means 1 is less than. Say this one no follow. Or we will just write them straight away. Say 0, comma positive infinity. And now like this we will write that. So this one now the range of that function. And when I don't see say we don't learn something well for this piecewise function. We make us they learn how to determine the domain and the range of the function. Now before I come out, we fit evaluate a function too at a particular point. But I no go inside that one. We go make that one for another class. Now, what thing we don't learn here so far, they straightforward. We say, for the sake of the class, say a piecewise function. Now, we dey learn. Piecewise function. And piecewise function, what thing be that? Say a collection of other small functions where they make a particular function. Smaller function where they make function. Now, this other smaller function, then get their own domain in them. Where you go from them, determine the domain of this one, and from those domains, you go see determine the range and form the range of this one. Now, I also tell on of different cases where they're very important. Like the first case, I said different types of piece function, you feel like them in different ways. Functions, you can get them as constant functions. Sometimes you can get them as algebraic functions. They can be trig functions. Different types of functions dey when we don't look. Now, I don't tell you say special kind dem dey. There are some way we do where we get numerator and the denominator. I say if you get that kind of thing, make sure say the denominator no get domain value wey go make am 0. If you make am 0, then wahala don dey. That kind of mathematics no dey. For Bekee, we dey call am undefined. When the under don't become 0, na wahala be that. That kind of mathematics no dey. So any domain value wey dey take, you go make sure say any number wey go make that thing 0, you go comot am. If not, you go make the mathematics yeye. Now, the other case we are come tell on again, na this kind of one wey get function wey get square root. If you get square root, you go dey very careful. Now, inside square root, if you put minus, number wey get minus, value wey get minus, you go see say e go give you complex number. You go see say e go give you complex number. And when e don give you complex number, that complex number no dey inside the real number set. So that kind of thing will no work. So when you dey deal with something wey get square roots, my brothers and sisters, you go dey very careful. For anything wey go give a minus, when minus don dey inside square root, e go give you that complex number. And after those ones, we don also learn how to write these intervals in a compact way. Now, these things the way we dey write here, as 1, 2, 3, all this one, now the same thing wey we dey write here. But this one now dey in a more compact way. And on our way we wan write exam, this is the way I dey write. make una really understand am well well. Make una really understand am well well. So that e go, una go really understand, because una wey dey write exam na sometimes dem fit give una this one, dem fit give una this one. Maybe you know say, hey, na this one I like, so na this one I wan learn. Learn all of them. So that if na this one come sef, you go really understand wetin e be. Na so the mathematics dey. And na so we wan also bring the class to an end. I believe say una enjoy this class well well. Next class, we go learn other things. Next class, we go learn other things so that we go get better understanding for the thing wey we dey call calculus. For now, una bye.